Okay, sorry about that. I accidentally hit end recording instead of pause. So this is 6.3 part 2. Don't worry guys, there's not that much left. So we have here two chords intersect within a circle. The products of the length of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So let's say we have this given circle O, and we have chords RS and QT. They intersect at some point V, okay? And we want to show that the product of RV and VS is equal to the product of TV and VQ. Well, this can be accomplished by proving two triangles similar. Okay, so here we go. So we have here, so given above, right? We want to show that this is true. Well, what kind of angles are created when you have these two intersecting line segments here? Angle 1 is congruent to angle 2 because of vertical angles, right? Right, by vertical angle theorem. So you would call that's a favorite of us. So also, let's draw auxiliary lines RT and QS. So drawing auxiliary lines, line segments, RT and QS. We have that. So see here, they intersect. You have angle R, TRS, or angle R, and angle Q. So you have angle Q. They're intercepting the same arc. Okay. Are both intercepting arc TS. Okay? So the measure of angle R is equal to a measure of angle Q. Angle R is congruent to angle Q. So we have that angle 1 and angle 2 are congruent, and angle R and angle Q are congruent. So we have two angles. So this guy is congruent to this one, and this is congruent to that by vertical angle. So we can say now that this triangle, we'll have triangle RVT is similar to QVS. So triangle RVT is similar to triangle QVS by angle-angle theorem. So we have that. So since that's we have, so remember CSSTP, corresponding sides of similar triangles are proportional. We can say that RV is to VQ as TV is to VS. So RV is to VQ as TV is to VS, right? They're proportional because these are similar triangles. So then it's just a matter of cross multiplying or means extremes. Then RV times VS is equal to TV times VQ, and that's it. That's what we wanted to show. Okay, great. So I think we have an example. So super fun example, we have that, oh, this is an H. HP is 4, PJ is 5, LP is 8, and we want to find PM, let's let that be X, okay? Okay, great. So let's use theorem 6.5. So by theorem, sorry, that means theorem, getting tired. So by theorem 6.35, sorry, excuse me, we can say that HP, the product of HP and PJ is equal to the product of LP and PM. So we just substitute. So let's just substitute their values. So 4 times 5 is equal to 8 times, and then let's let that be x. So that's 20 over 8, right? So x is equal to 20 over 8, or we can write that as 2.5. Okay? And that's it. So you say PM is equal to 2.5, I guess more exactly. Okay? So that's that. Next we have HP is equal to, oh no, we already did this, right? Oh no, we have a different one. So we have HP to 6, PJ is 4, and then the whole thing here is 11. So let's one of them be X. So if this is X right here, then the other piece has to be 11 minus X, because together they make up 11, okay? Because the whole thing is 11. So we just plug in, so 6 times 4 is equal to X times 11 minus X. So this is 24 is equal to 11X minus X squared, so distributing. So we get finally that X squared minus 11X plus 24 is equal to 0. Well, we can factor this. This becomes X minus 3, X minus 8. So X is equal to 3 or 8. So if LP is, so if X is equal to 3, we have that LP is 8, if X equals 3. We have two cases, right? We have LP is equal to 8, PM is equal to 3, and then we have if X is equal to 8, we have that PM is equal to 8, and the LP will be equal to 3. Okay, so that's that. Okay, I think in the book it has it flipped, but that's fine. It's the same. It's not, you know, they let this be X and this be 11 minus X, but it doesn't matter, because either way you get 8 and 3 or 8 and 3. Okay, great. So then finally, theorem 6.36, I think is an exercise. So, let's see if we have here that you have two secants, and if we wanted to prove AB times RA is equal to AC times TA. Okay, so the product of this side and here is equal to the product of the secant AC times TA. So the way to kind of do it is you draw two auxiliary lines, right? And you see they have the same, they intercept the same arc. So I'm just going to do, really quick, I'm just going to do a hand wavy kind of proof. So angle B is congruent to angle C, because since they intercept the same arc. They intercept the same arc, and then they're both inscribed angles. Okay. And then what else do we know? We know that A is congruent to itself, right? Reflexive property. So then we can say by angle, we say that triangle ABT is congruent to triangle ACR. Okay. So then we say then by corresponding sides of similar triangles are perpendicular, we can write that AB is to AT or TA as AC is to AR or RA. Okay, so we have the long end. This is the short end of this triangle. Is this long end is the short end, because they're similar. And then just cross multiply, and we get what we want, which is AB times RA is equal to AC times TA. And this is supposed to be an exercise, so oopsies. All right, so that's that. So let's use it. Okay, fine. So we have here that AB is 14 and BR is 5. So we have AB is 14 and BR is 5. So AB 14, BR is 5. I don't know why I wrote 15, sorry. So 14. And then we have that TC is 5. And we want to find AC and TA. Okay, fine. So let AC equal to X. Okay, so TA plus 5 is equal to X. So this is going to be X minus 5. Okay. And then we have BR is 14. And then this is going to be 9, right? By just subtracting. So then we have here AB by the theorem times RA is equal to AC times TA, right? So AB is 14 times 9, and that's equal to X times X minus 5. So we have 126 is equal to X squared minus 5X. So 0 is equal to X squared minus 5X minus 126. So subtracting both sides by 126. And then we just factor. So X minus 14 and X plus 9. These are the two factors of 126 that when you combine them together equals negative 5. So our possible answers are 14, positive 14, and negative 9. But we don't have, distance is not negative in our world, so we're going to only use 14. So X equals 14, so AC is 14, and that makes TA 9 also. Okay. All right. And then lastly, I think we have is last proof. If we have a tangent segment and a secant, the square of the length of the tangent equals the product of the length of the secant with the length of its external segment. Okay. So let me just explain this to you. So basically, I think this is going to be an exercise. So this is an exercise. So I want you guys to try it. And the proof comes from, let's say you have, we're trying to show auxiliary, we draw these auxiliary lines and we show that TVW, this big one, is similar to TXV. Okay, so TVW similar to TXV. So that's an exercise. So proof is an exercise, but I just want to explain to you. So TV, so the square of this this length of the tangent equals the product of the length of the secant. So this is the secant, so the product of the length of that with the length of its external segment, TX. Okay? So length of secant, length of tangent of the circle, and then this is the length of secant, and this is the length of external segment. Right? The outside. Okay, so that's that. So let's use it. Here we go. So here we have, okay, so we have here the product, the length of the tangent, right? So ST is going to be squared is equal to the length of the secant times the length of the exterior segment, which is SV. Okay, so that's that. So obviously, like, you know, you just need to understand how to use these guys. So we have the square of the tangent is equal to the length of the secant times its exterior point. So here we just plug in. We're trying to find ST. So let's just go ahead and plug in stuff. So we have ST squared is equal to, and then we have SR. We don't know what SR, but we do know what VR is. This is 9 and this is 3. So of course SR by segment addition postulate is going to be 12. So 12. And then SV is 3. So we have ST squared is equal to 36. So taking the square root, we have ST is equal to 6. Okay? Okay, so that's it. And then Your super fun homework is to just do 1 through 25 on. If you want to go ahead and try 47, sure, I'll take a look at it. And hopefully this was helpful to you, and I will see you guys on Tuesday at 7 p.m. via Zoom. I will send you a link shortly, and then you guys can ask any questions from the homework. And we will I'll also be sending a quiz on Chapter 6, key concepts and exercise problems. So I'll see you guys soon. Okay, bye-bye.